Welcome to The Explainer. Today, we're diving into something that could completely change the game for software development. We're talking about an AI that doesn't just write code, it actually seems to think in it.
So you've probably seen those AI assistants that can whip up some code, right? And yeah, they're getting pretty darn good. But have you ever noticed what happens when you give them a really tough problem? Like a nasty bug hidden deep inside a huge project? That's where they tend to trip up. So what are they missing?
It really comes down to this classic idea in programming: syntax versus semantics. Think of it like this. Syntax is the grammar. Does the code look right? Does it follow the rules? But semantics, that's the meaning. What does this code actually do when you run it? And that's the huge gap we're talking about.
All right, let's really dig into this blind spot, because this is where most AI models today fall into what you could call a syntax trap.
So, if you think about how most of these AI models learn, it's basically by predicting the next word, just like with regular text. So for code, they get really good at predicting the next chunk of code. They become masters of syntax. The code they write looks perfect. But here's the catch. They don't really get the consequences. They don't have a gut feeling for what's actually going to happen when that code runs.
So to get out of this trap, some researchers at Meta came up with a pretty radical new idea. What if we could give the AI a world model just for code?
They call it a Code World Model, or CW for short. And the whole point isn't just to teach an AI what code looks like. No, the goal is way bigger. It's to give it a deep, almost intuitive grasp of what code does. It's like it's building a little mental simulation in its head, tracking how everything, the variables, the memory, changes with every single line of code.
And this is a massive shift in how we think about this stuff. A traditional AI is kind of like a cook who can read a recipe perfectly, but they've never actually set foot in a kitchen. A code world model, on the other hand, is like a real chef, one who's been in the test kitchen and understands from experience exactly what's going to happen if you add a pinch more salt. It's moving from just reading the cookbook to actually understanding the cooking.
Okay, so the big question is, how in the world do you actually teach an AI to think like that? Well, it turns out it's a two-step dance. First watching, and then doing.
So for the watching part, the researchers basically had the model binge-watch millions of what they call Python execution traces. The best way to picture this is like a super slow-motion replay of a program running. The AI gets to see, frame by frame, exactly how each line of code makes a variable change. It's learning cause and effect, one step at a time.
All right, then comes the doing part. They built this AI agent called Forager Agent and dropped it into, get this, a coding simulator. It's basically a flight simulator, but for software engineering. The agent gets thrown real-world tasks. Hey, here's an error message, go fix the bug, or go add this new feature, and it has to figure it all out by itself, learning through trial and error. So after all that watching and doing, did it actually pay off? Let's take a look at the results, because they are seriously impressive.
They put it to the test on this benchmark called SWE-bench. And what's cool about this one is that it uses real issues pulled directly from GitHub projects. We're talking real-world problems. And the Code World model, it didn't just do well. It blew other open-source models of its size right out of the water.
So just how much better are we talking? Well, it hit a 53.9% success rate on its first try. Now, that might not sound like 100%, but for this benchmark, which is notoriously difficult for AI, that number is absolutely massive. It's a huge leap forward.
But here's what's maybe the coolest part. We can actually peek inside and see the model's internal monologue, its thought process. And what does it say? Okay, I need to solve this problem. Let me create some test cases. I mean, come on. That is exactly how an expert human developer thinks. You don't just dive in. You figure out how you're going to test your solution. This isn't just matching patterns anymore. This is real problem solving.
And this ability to reason about the problem leads to a pretty incredible superpower. It basically turns the AI into what you could call a neural debugger. It can simulate the code in its head, predicting what's going to happen to all the variables step by step without ever having to run the code. That's a game changer.
So let's step back for a second. Why is this such a big deal? I mean, this is so much more than just a fancier autocomplete. What we're looking at here is a fundamental shift in how AI understands the very logic of software.
Okay, so what does this unlock?
First, way smarter, way more reliable coding assistants, ones that actually get the consequences of what they're suggesting. Second, you can imagine AI agents that can just go off on their own, hunt down complex bugs, and fix them without any human help. And maybe most importantly, this whole idea of teaching an AI a world model isn't just about code. It's a huge step towards building more capable, general-purpose AI that can understand any complex system.
And that leaves us with a really fascinating question to chew on. The world of code, it's a universe of pure logic, right? It has hard rules, clear cause and effect. So if an AI can learn to truly master this world, what world is next?